Hi, I am Nikhil. I am pursuing my Masters in Embedded System in VIT Chennai. In this video, I will demonstrate the array functions in LabVIEW. Before going into array functions, we need to know about what are arrays. Arrays are nothing but collection of elements of same data type. That is, whenever a user wants to store a collection of values which are of the same data types, then we go for arrays. Whenever a user needs to store a collection of elements which are different data types, LabVIEW supports one more data type called as clusters. Arrays are ideal for storing data that which we collect from waveforms, graphs, data generated in loops, or data collected from multiple sensors. Array elements are stored in continuous memory locations, so accessing individual elements will not be a problem in arrays. An array can have any number of dimensions. For example, array can have a single dimensional array, two-dimensional array, or multi-dimensional array. But one thing common in all dimensions is every dimension can have maximum of 2 to the power of 31 elements. Most probably in all the physical world problems, you will be working with either one-dimensional array or two-dimensional array. One-dimensional array is used for vector representations. Two-dimensional array is used for problems relating to matrix representation. Now concentrating on one-dimensional array, as I have already said, one-dimensional array is for vector type of problems. This one-dimensional array can be created by placing an array shell on the front panel and putting the numeric data items in that shell. The array shell can be accessed from the front panel by going to Controls, Mod Run, and Arrays. The elements in one-dimensional array have a single pair of indices. So, to access these elements, only one pair of indices are sufficient. The second most used type of arrays is two-dimensional array. They are frequently used in data acquisition application and are either represented in matrix form or grid form. To access any element in two-dimensional array, we need to specify two indices. That is, one for row indices and one for column indices. These are the two various most commonly used arrays. Now we will go and check the various array functions which are available in LabVIEW. The various array functions which are available in LabVIEW are these. Now we will see one by one what are these. First we will go for array size. Before going to array functions, we will create an one-dimensional array so that each and every time we can use this. Now I am creating an one-dimensional array. For that we have to go to array. In this array we have to set this array shell and we have to place this numeric control inside it. Now we can add as many elements inside this. 1, 2, I have added 7 elements in this array. The array first indices will be 0 and it starts from 1, 2, 3, 4 like that. Now we are dealing with array size. Means this function will give the number of elements in that array. For this array, the input will be for this function the input will be the array, and we will create an indicator and we will run this. The size is giving is 7. This indicating that the 7 elements are present in this array. Now we will go for the next function, which is called as index array. This gives the element which is present at the index position given by the user. The index position which we are accessing is let it be at position 1. Now we are taking the same array and we are finding the element at the first index. We are getting the output as 2 because this is the index 1 and this output is reflecting here. Now we will go for third function called as replace array subset. This function replaces the array at that point where we specify. In this this is a replace array subset function. For this we are considering this array, and at the first index the element there is 2 and we are changing the element 2 with the element 5. Now we will create an indicator and try to run this program. Earlier at the first index the element was at 2, but after we have inserted 5 at the first index we can see the element is 5. So this is what a replace array subset does. The next function is insert into array. This function inserts the element into array at whichever indices we tell. We are taking the array and we are at the index 1 we are inserting an element 5 and we are displaying it through an indicator. Before at the first index the element was 2. Now after inserting 5 the element at the first index is 5. This is what insert into array function does. We will go into next array function which is called as initialize array. This initialize array means it takes this first constant, it tells the data items which are present in the array, and this 3 tells the number of indices, means it will have 3 indices and the elements present in 3 indices will be 5. We will keep an indicator and see what is happening inside it. Three indices are created and the elements inside three indices are 5. This is how initialize array works. Now going for the next function, it is build array. User can enter various elements into this, and this build array function concatenates into a single array. We will enter some 3 values. We are giving the elements as 2, 3, 6, 4 into build array. This concatenates all the elements and produces a single array. We can see here it has concatenated 2, 3, 6, 4 and produced a single array. This is how the appended array works. The next function is array subset. This array subset accepts the array and based on the indices and lengths, it gives the subset from the main array. We are taking this array, and from the indices first we are making a sub array of length 3. Means it has to start from 2 because it is the first index, and it has to run till 2, 3 and 4. We will check whether the same output we are getting or not. 2, 3, 4, because indices is 1. This is from 2, it starts because it's the first index, and it runs till 2, 3, 4 because you have specified the length as 3. The next array function is maximum and minimum. This maximum and minimum function is very simple. It just accepts the array input and gives the maximum element which is present and its indices, and the minimum element which is present and its indices. Let us see how it functions. The same array we will take and we will create the indicators. Out of this array, the maximum element is 7 and its indices is 6, and the minimum element is 1 and its indices is 0, which is clearly visible from this array. The next array function is reshapes array. This function reshapes the given array based on our required dimension. The next array function which we are looking is reshape array. This reshape array changes the dimensions of the array based on our requirement. We will see how this works. This is the dimension size which we have to, which is required in the output array. This is the required array. We have given the required indices is 3. So only the first 3 elements are printed. This is how the reshape array function works. The next array function is sort array. It just accepts the input and sorts the element. We can see that in the sorted array, the elements are all sorted in the ascending order. This is how the sort array function works. The next array function is search. This search array checks the element in the array from the indices which we are specified. If the element is found, it prints the indices. If the element is not found, it prints the indices as -1. We have to be very careful while specifying the indices. Even if the element is found in the array, and if you specify the starting wrong indices, then the element may not be found. We'll put the search element as 5. We are taking this array and we are searching for the element 5. That is, in this array we are searching for the element 5 and we are giving the start index as 0. That is, we are making the program to start searching from first indices. The element 5 is found at the fourth indices. Now, if we change the starting point from which we have to search, assume we will keep it as 6. Even though the element 5 is present, since we are starting from this indices, that is, the program starts searching from 6 and 7, and the element 5 is not found, so it is giving us -1, which is telling that the element is not present. So we have to be very careful while giving the index for search. The next array function is split. This array function divides the array into two parts depending on the indices. Until the third indices it will be in the first subarray, and after the third indices it will be present in the second subarray. Now let us see how it works. We can see that first three elements are in the first subarray and the rest elements are in the second subarray. This is how split array works. Now we will go for the next array function, which is called as reverse one-dimensional array. This reverse one-dimensional array accepts the array and performs the reverse. That is, this reverse array function has obtained this array as input and it has printed the elements from the last, which is visible from this reversed array. This is how reversed array function works. The next function is rotate array. This rotate array function accepts the array, and based on the number of times it rotates the elements from bottom to top. We can see that the elements are rotated twice, so that the 6 has come to the top, which was at the second most position from the bottom. This is how rotate array works. The next array function is interpolate one-dimensional array. This interpolate one-dimensional array function accepts the array and one constant, and it gives us the interpolated value. We can see that it has obtained the array and the indices is 2. So in that the second indices, the interpolated value is 3. So it is the output. This is how interpolated array works. The next array function is interleave. Interleaved array means it combines the array. It takes two arrays and combines the elemented two indices. We will take the same array and check how it combines. We can see that the elements in the two array have been combined. This is how interleaving of two arrays. It is just of combining two arrays and producing a single array. The next array function is decimate. It just divides the array into two parts. This decimate array function divides the array into two parts 1, 3, 5 and 2, 4, 6. If there are any elements which makes the array not to divide in equal parts, such elements will be skipped by this function. Till now we have seen the array functions on one-dimensional array. Now we will see the array functions on two-dimensional array. This is transpose two-dimensional array, which changes the rows in the two-dimensional arrays into columns and columns into rows. Let the input array be 1, 2, 3, 4 and we will run it. This transpose array function has changed the columns into rows and rows into columns. This is how transpose of two-dimensional array works. And the next array function is array to cluster. Means it takes the array as an input and gives the output as cluster. We can see that the array has been converted into cluster, and there is one more function called as cluster to array. This accepts cluster as an input and gives us back the original array. We can see that through this we are able to recover the original array. And the next array function is array to matrix. Means it converts the two-dimensional array into a matrix form. We can see that this array to matrix has converted the array into matrix elements. This is how this array to matrix works. And there is one more function through which a matrix has to be converted into arrays, and that function is called as matrix to array. We will give matrix as input and we can obtain array back. We can see that the original array has been recovered. These are all the various array functions supported by LabVIEW. Thank you.